Hey everyone, I'm going to be teaching you all about class 11 chemistry first chapter mole concept. And since this is the first time I'm making this video, I'm going to be dividing this chapter into few parts. Separately, I'm going to be making a video about each part. And today in this part, I'm going to give you introduction of this chapter and I'm going to tell you overall what all are there in this chapter. Okay, so to start with, this chapter right here, mole concept. And in this chapter, we have topics like first we have classifications of matter. To give you guys the brief introduction of this chapter, at the starting, we have classification of matter. And all of you know that matter is based on three classifications, that is solid, liquid, and gas. Over here, we have classifications such as pure substances and mixtures, and we have more classifications inside them. And after this, we are going to be learning about chemical laws, laws of chemical combination. Laws of chemical combination is going to give you laws about how different combinations are possible. And yeah, after this, we are going to be learning about Dalton's atomic theory. After all of this, we are going to be learning about the main concept of this chapter, that is mole concept. In mole concept, we have calculations based on molarity, molality, percentile composition, and all of that. So this is basically it. To start today's lecture with, I'm going to be starting with the first topic, that is classification of matter. Matter is classified as this. So first we have over here matter. So matter is divided into two parts. That is, as you all can see, first part over here is pure substances. So this is the first time I'm writing on the board sort of thing, so don't mind my handwriting and all. Okay, to start off this, we have pure substances as the first classification, and second classification is mixtures. That is, here we have mixtures. As you all know that pure substances basically are the ones in periodic table, that is hydrogen, and like you can't basically divide them. They are like connected, like they have. So to start off this with, here we have pure substances. As you all know, pure substances have fixed composition and they cannot be separated by applying force and all of that. And to start off with, in pure substances, we have examples such as hydrogen, like H2 bond, and water, and all that. Simply to state that they have simple composition, and they have fixed composition. Yeah, it's the same thing. So pure substances right here can be also classified into two types. Those two types are, so pure substances right here have simple composition, and the same thing as fixed composition. So they have simple composition and fixed composition. Like hydrogen bond, you have H and H, and they are bonded by covalent bond. Yeah, like just like that. And pure substances can also be divided into two types. That is, those two types are, one is so right here two types. Those two types are elements and compounds, right? So those two types are elements and second type is compounds, you know. So these are divided into two types, that are elements and compounds. As I have said before, elements are the ones you find in a periodic table like hydrogen, helium, lithium and all those. And to define elements, elements are the ones you find in periodic table, such as hydrogen, helium, lithium. But the thing about elements is they have only single element and the composition only contains single element and the elements cannot be divided. So to look at this, in elements we have single element bonds, such as if you see hydrogen atom, that is here, here, and valency of hydrogen atom, you need 2. So the first shell of hydrogen needs 2 to be stable. Even this thing also needs 2 to be stable. But hydrogen atom only has one electron over here. They don't have 2 electrons. So what they do is they share their electrons. So this thing will share 2 electrons and this thing will share 2 electrons, forming a covalent bond. So thing about elements is they only have single composition, like only hydrogen and hydrogen. They are not pairing with other, like like water has 2 hydrogen atoms and 1 oxygen atom. In elements there's only 2 hydrogen atoms, but in compounds it's a different thing. In compounds you can have different type of atoms in simple compositions, like for example you have water. Water is basically H2O. H2O meaning H2O. Over here you have 1 oxygen atom. No, yeah. Okay, so hydrogen, hydrogen. So these things will also form a covalent bond with each other and like this. So this is 1 hydrogen atom and 1 oxygen atom. So compounds basically don't prefer one. I mean even one can be there, but they have mixture of pure substances that form different compounds like H2O, that's water. As I said before, in elements there are only 2 times, but in compounds there are more. So compounds can be further divided into different kinds of bonds, that is ionic and covalent. They are divided into 2 kinds of bonds, that is ionic bond and covalent bond. Ionic bond is basically when, this atom, like this atom, so like this, and then the second shell, see, I'm drawing this as first shell, okay? This is first shell and this is second shell. As you all know, to fill the first shell, you only require 2 electrons, but to fill the second shell, you require 8. But suppose this thing has only like 6 electrons and it's missing 2 electrons. So its valency is 2. So this element needs to join with other element that provides 2 electrons to it. So that is known as ionic bond. So basically to say this in words, ionic bond is when one element shares electrons with other elements and it forms a stronger bond. But as I told earlier, covalent bond is formed with hydrogen, like hydrogen share electrons. Here one is not providing the electrons. So that's basically covalent bond, like H bond, and we have H2O. bond. So this is basically ionic bond and covalent bond. So this is all the most simple composition we have in pure substances. Now coming to mixtures. Now coming to mixtures. To define mixtures, first we have in mixtures as homogeneous mixtures and heterogeneous mixtures. So let me just write them down. So we have first over here homo and second part we have heterogeneous. Heterogeneous. So now in homogeneous we have uniform composition and in heterogeneous we have non-uniform composition. So if you look at homogeneous, I'm going to be dividing this table like this. So in homogeneous we have first point uniform composition. So in homogeneous we have uniform composition. Basically uniform composition is when they have like certain composition ratio. Like you see like in hydrogen to I'm going to be giving simple examples, okay? So in water we always have two hydrogens and one oxygen and the ratio is 2 is to 1 and those kind of compositions are known as uniform composition. And examples of uniform composition here can be like NaCl plus H2O, like adding water with sodium chloride. So examples over here are this is an example of uniform composition. And these compositions are mostly based on alloys. You know, like alloys. So you just write alloys as the example. So uniform composition and alloys. So this is all a sector of homogeneous. After homogeneous, we have heterogeneous. Heterogeneous is like, as you can guess, if homogeneous is uniform, heterogeneous is non-uniform, okay? So we have over here non-uniform composition. See, just don't mind my handwriting, okay? Like, I'm first time writing it on the board, so okay. So in heterogeneous, we have non-uniform composition. Like examples of heterogeneous can be given as you see. Basically, heterogeneous is when composition doesn't matter. Like any kind of composition can be possible. Like there's no fixed ratio. Like you see, elements can be anything. Like it's like basically all elements are combined together. There's no proper order in them. So that's what heterogeneous is. Examples of heterogeneous can be like, diamond, graphite, and even like sand and water. Like you mix sand and water. That's also an example of heterogeneous. So I'm going to be writing down the examples right here. So first one is diamond. Second one is diamond and yeah, I was saying graphite. And the third composition we have is sand and water. Sand, I don't think so. Sand is a good example. Instead of that, we can cancel sand. We can write salt. Salt and water. So I forgot to add one point. When I meant graphite and diamond, I meant like both of them together make a non-uniform composition. And the word here, water and salt together make it, okay? So that's the thing about heterogeneous. So to summarize what we have learned today, here the first components elements. So elements have only one kind of atom. So to summarize what we have learned today, first elements. Elements only have one type type of atom. Like elements only have one type of atom, okay? Elements are only made up of one type of atoms. And other example of elements is oxygen bond, like O2 bond. O2 meaning one atom of oxygen, one atom of oxygen. They only have one type of atoms, okay? Yeah, they have only one type of atoms. But in compounds, we have one or more types. So in compounds, we have more than one or two types. Like the previous example I have given, water. Water has like two types of atoms, that is hydrogen and oxygen. So it has two kinds of atoms. So that's basically compounds. But to summarize homogeneous and heterogeneous, homogeneous compounds, like if you have a compound, a homogeneous one, it has uniform density. As I told, they are made in proper ratios. So like not exactly ratios, but like proper. They have a proper order. So the density throughout this thing is always uniform. Like uniform density throughout. But in heterogeneous, we have non-uniform density throughout. So we have two kinds of compounds, that is uniform density and non-uniform density. So that's basically it. And yeah, that's a classification of matter. And though that's the most simplest possible classification of matter possible. Even though this is not that much important for JEE, it's just a basic knowledge. And this lecture just deals with the classifications of atoms. And from next lecture onwards, like from next parts of this lecture onwards, I'm going to be teaching you all the important stuff, like Dalton's atomic theory and the laws of chemical combination, and those are the important to know to get good marks in this chapter. And yes, here is the whole composition. Even though my notes are not like in proper order, because this is the first time I'm writing them on a big chart. And yes, this is basically the first part of this chapter, and I'm going to be uploading more videos upon this chapter in the future. Thank you.